Hi, thanks for joining me today. I'm really glad you're here. Today we're going to talk about a subject called function notation. Function notation is something that we use quite a bit in mathematics, and it's really kind of a helpful tool for us. It's used when we're dealing with functions. So when you see function notation, the nice thing is you know that we're dealing with a function. It identifies that you're working with a function. It identifies the input variable as well. And we'll see an example of that here in a little bit. But it's nice to know what input variable we are working with as we are looking at the function. And it's also a shorthand way of asking you to evaluate given a particular input. And we'll see examples of both of these things here in just a second. So it's written as, so here we have function notation shown. We would have an equal sign after this with what the function is, but just as an example, f of x, f is a common used letter for function notation. So you might see this as f for function, but it is a function f in terms of x. So we would read this f of x. Okay, here is another example. This time we're using g. So this is function g, a function g in terms of t, and it is read g of t. So in our first example, we have two functions. We're given f of x is equal to 2x plus 1, and g of t is equal to t squared plus 5. So the first thing we're going to do is we're going to put in some numbers and evaluate. So in the first example, we want to find f of 3. So what that is saying is, notice we took out the input variable and we put a number in its place. So what that is asking us to do is evaluate function f at the input of 3. So for our answer, we would say f of 3 is equal to, well, we bring down the function 2x plus 1, but since we're looking for what x value of 3 would be, we plug in the 3 instead of the x. So now we can go ahead and start simplifying. 2 times 3 is 6, and 6 plus 1 gives us 7. Okay, so we're going to do that same sort of thing here with our other function, function g. Find g of negative 2. So again, what that's telling us is put in negative 2 in place of our variable, our input variable. So g of negative 2 is equal to, well, remember g was t squared plus 5. So we're going to put in negative 2 in place of t. So negative 2 squared plus 5. Negative 2 times negative 2 is positive 4. So 4 plus 5 gives us 9. Okay, it's also useful if we want to put in, say, a different variable. So here in example C, it says find g of a. So instead of finding g of negative 2 or g of some other number, we're finding g of a. So again, all this means is we're going to take our input variable and we're going to replace it with what's inside here, which is a. So instead of t squared plus 5, we now have a squared plus 5. Okay, so we'll do one more example like that. Find f of b plus 5. So notice here we have a different expression even that we can put in place of x. So for our answer, f of b plus 5 is equal to, well, remember 2x plus 1, we're going to take out the x and replace it with b plus 5. So 2 times b plus 5 plus 1. Remember, we do have to distribute the 2, so 2b plus 10 and then plus 1, so we end up with 2b plus 11. Okay, for example 2, this time we're going to look at it using a table of values. So using the given table, find each function value. So here we have our function f, and we have some input values and we have some output values. So in A it says find f of negative 3. So all we have to do is look down on our table here and find negative 3. Well, it happens to be right here, and f of negative 3 is 7. So when we're using a table, it's just a matter of looking here, finding what one we're looking for, which in this case is negative 3, and finding the output, which is 7. So our answer, f of negative 3 equals 7. In B, find f of 0. So again, go down and find where the input is 0, and our output value is right here, so f of 0 equals -4. Okay, in example C, we can work with it the other way. Find x when f of x equals 23. So this time we're going to look on the side of the column where f of x is. F of x is 23 right here. And so we're looking for what that x value is. Well, f of 1 is equal to 23, so x must be 1 in this case. Okay, again, we can do that same sort of thing with a graph as well. So this time, given the graph, find the following. So first, find f of 0, f of -2, f of -3, and f of +3. Okay, so first of all, f of 0, well, remember that's when our input value or our x value is 0. So if we look here where 0 is on the graph and we go down, notice that at 0, f of 0 is -3. So our first answer right here is -3. Okay, f of -2. So if we go -2, it looks like right here, f of -2, what's our y value? Well, in this case, it's 0. So f of -2 is 0. Okay, f of -3. So if we go back to -3 and we follow it on up, it looks like the output value is about 2. So f of -3 we will say is 2. And then f of +3. Well, if we go over here to +3 and go straight on up, it looks like our y value is about 3.5. So 3.5. Okay. Next one, find all values where f of x equals 0. Well, we found one of those already up here in our previous problem. So if we look here, where is our y value 0? We'll notice we have 1 right here. So f of -4 equals 0. Our next one is right here at -2, so f of -2 equals 0. And our final one is over here at +2, so f of +2 also equals 0. Okay, find x when f of x equals 4. So this time we need to go over here to y equals 4, go on over, and then follow it on down. And it looks like it is about 3.5 in the x direction. So f of 3.5 equals about 4. Okay, we'll do one more example here. Okay, example 4. So let's say this time we're going to have a word problem. So on summer vacation, you take a trip to California. On the second day, your distance from home is represented by this function d of t. So notice I use something that kind of makes sense here. Since we're talking about distance, I use d to name our function. And we're talking in terms of time, so I used t for time. So the distance in terms of time is equal to 55t plus 200, where t is the amount of time spent driving. So question A, how far from home will you be after 5 hours of driving? Well, notice since we're talking about t time, that is our input value. So we're going to find d of 5. And d of 5 is 55 times 5 plus 200, which is 275 plus 200, or 475. Okay, in the next one, the place you want to stop at for the day is 750 miles from home. How long will it take you to get there? So this time we're asking about a distance, so it's going to go on the other side in place of our d of t. So d of t is 750. So 750 equals 55t plus 200, and now we just have an equation to solve. So subtract 200 from both sides. We get 550 equals 55t, and divide both sides by 55, and we get t equals 10. So you would spend 10 hours driving for that trip for the day. Okay, well, I hope this helps you in your understanding of function notation, and I'm sure I will be seeing you again soon. Thank you very much.